Hi everyone. In this last video, we're going to talk about at least once, or finding the probability of at least one occurrence of something. And I'm going to start off by using the example of if I'm rolling a die 4 times, what's the probability that we will see a 6 at least once? So first notice that rolling a die is independent, right? One roll does not affect the other roll. But if I want to calculate the probability of at least once, it would be really hard for me to calculate this straight up. I have a lot of combinations of ands and ors because the order matters. So say I roll a 6 on the first roll and not the last 3. So I would roll a 6 and not a 6, not a 6, not a 6. Or I would not roll a 6 and then roll a 6 and then not a 6, not a 6. Or I could not roll a 6, not roll a 6, roll a 6, and then not roll a 6. Or I haven't even gotten through the ones yet, right? Or I could roll a 6, not roll a 6, not roll a 6. There are a ton of different combinations here. You don't want to make this calculation straight up. So what we want to do instead is use our complement rule, because the complement of rolling at least 1 is rolling no 6s. So I want you to think about all the scenarios of rolling a 6. We could roll 1 6, we could roll 2 6s, 3 6s, 4 6s, or no 6s. So at least 1 would include the 1, 2, 3, and 4. But it doesn't include the scenario of no 6s. So the complement of at least 1, 1, 2, 3, 4, is none. So we use this idea that the probability of at least 1 is 1 minus the probability of none. So if I want to find the probability of rolling at least 1 6, then I want to actually calculate 1 minus the probability that I don't roll any 6s. Well, if the probability of rolling a 6 is 1 6, then the probability of not rolling a 6 is 5 6. And I'm doing this 4 times. So the probability of no 6s would mean that I wouldn't have a 6, and then I wouldn't have a 6, and then I wouldn't have a 6, and then I wouldn't have a 6. Right? So 4 in a row of not 6s. And if you want to, you could write this as 1 minus 5 6 to the 4th power. So in your calculator, you would do 5 divided by 6, raise it to the 4th power, and then do 1 minus that answer. And you will get 0.5177. Let's try another one. So it says, items are inspected for flaws by 3 inspectors. If a flaw is present, each inspector will detect it with a probability of 0.8. The inspectors work independently. If an item has a flaw, what is the probability that at least one inspector will detect it? So the probability that an inspector will detect a flaw is 0.8. So then the probability that they don't detect the flaw will be 1 minus this, right? The complement of that. But we want to find the probability that at least one inspector detects the flaw. So at least one detects the flaw. I don't want to look at all the different scenarios of at least one, which would mean 1, 2, or 3 in all of the different orders that we could have. Instead, we want to use the complement and find one minus the probability that none of them detect the flaw. So this would mean that all 3 do not detect the flaw, which was a probability of 0.2, but I have that 3 times since there's 3 inspectors. Or this would be 1 minus 0.2 cubed. If you put 0.2 cubed in your calculator and then do 1 minus that, you'll get 0.992. So there's a 99.2% chance that at least one of the inspectors will detect the flaw. All right, so for this last example, I just kind of want to do a little bit of a summary of the different things that we've done. So in this case, it says, in its monthly report, the animal shelter states that it currently has 24 dogs and 18 cats available for adoption. 8 of the dogs are male and 6 of the cats are male. Suppose an animal from the shelter is randomly chosen. We're going to find these probabilities. So it says, what's the probability that the animal is male? Well, in order to know that, we need to know the total number of animals and the total number of male animals. So if we have 24 dogs and 18 cats, that gives us a total of 42 animals. So I'm just going to kind of say right here that we have a total of 42 animals, 42 dogs and cats. And we have 8 male dogs and 6 male cats, giving us a total of 14 male animals. So when we look at the probability of selecting a male animal, this is going to be the probability that they're male divided by the total number of animals, and we get 0.33. Now let's figure out the probability that the animal is male given that it's a cat. Remember that this formula is the probability that it's male and a cat divided by the probability that it's a cat. Or we can know that we're only talking about cats, and there are 18 of them. And how many of those 18 cats are male? 6 of them. So 6 out of the 18 cats are male, and this is also 0.33. Let's turn this around. What's the probability that the animal is a cat given that it's a male? So I would have the same numerator, but we would have a different denominator. And again, I'm not going to use the whole formula. I'm just going to say, okay, I've got 14 males, 14 male animals. How many of them are cats? So 16 out of 14 of the animals, or the males, are cats. And this is 0.43. Are the events of selecting a male and selecting a cat independent? So which of these 3 probabilities do we want to compare? Remember that when we were looking for independence, we wanted to compare the probability of A with the probability of A given B. So we have that up above here. We have the probability that the animal is male is 0.33, and we also have that the probability that the animal is male, given that it's a cat, is also 0.33. And since these are the same, these events are independent. The fact that the animal was a cat had no effect on the probability of it being male. If you choose to randomly adopt two pets, what's the probability that both of them are cats? Now, when you adopt a pet, you don't adopt a pet and then put it back and then adopt another pet, right? So this would be considered without replacement. You're going to adopt the pet and keep it and then adopt another pet. So what's the probability that they're both cats? Oops. So the probability that the first animal that you adopt is a cat, I don't want to write this. I want to go right to writing it. So the probability that the first animal that you adopt as a cat is 18 out of 42. But now the second animal, you've taken a cat, you've adopted a cat, so now the total number of animals is reduced to 41, and there are also only 17 cats left. So the probability that the next animal is also a cat is 17 out of 41. And when you put those in your calculator, you get 0.178. And then the last one, what's the probability that at least one of these two pets that you adopt is a cat? So remember, at least one means 1 minus the probability that none are cats. So that would give us 1 minus, if none are cats, it means that both of them are dogs. So the probability that the first animal is a dog is 24 out of 42. But again, we're not replacing, which means that the probability that the next one is also a dog would be 23 out of 41. So if you multiply those together and then subtract from 1, you'll get 0.68.